Alright, Chapter 5, Lesson 1 is about midsegments of triangles, and the objective is to use the properties of midsegments to solve problems. So first, the vocabulary and key concepts. There is a new theorem this chapter. This is the triangle midsegment theorem, which states if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half its length. So a couple things to talk about to go along with that. First of all, a mid-segment of a triangle is a segment connecting the midpoints of two sides. So if it's a midpoint, that means it cuts the line in half. So each of those pieces are going to be equal. A coordinate proof, which we won't go into a lot of detail on this, but it's a form of proof using coordinate geometry. Oops. And algebra. Now, the reason they bring this up in this chapter is because you can use coordinate proofs to prove the midsegment theorem. So they set up the triangle perfectly on a coordinate plane, and then they go about proving things for it. Okay, let's try some examples. So first, we're going to find the lengths in triangle X, Y, Z. M and P are midpoints. The perimeter of M and P is 60. First, we're going to find NP and YZ. So we know the perimeter is 60. So if we add up each of these pieces, it has to add up to 60 by the definition of perimeter. Then it says MN is 24 and MP is 22. So we're going to plug those in. Still equal to 60. So all we did was substitute 24 for MN and 22 for MP. If we add 24 plus 22, we're going to get 46. That's still equal to 60. All we did was add those two numbers. Then if we subtract 46 from each side, we can find that NP is 14. Then we're going to use the triangle midsegment theorem to find YZ. So we know that the midsegment is half the length of the actual triangle. So MP is half YZ. This line is half of this bottom line. Okay. Well, we know MP is 22. And that has to be half of YZ. So then if we multiply by 2 to get rid of that half on each side, we'll get 44. So YZ is 44. Okay, so the midsegment theorem can be used to find a lot of different segments. Okay, number 2. Find angle AMN. MN and BC are cut by the transversal AB. Okay, so let's look at those two sides. MN and BC, they're saying these are parallel lines, and they're cut by this transversal. Oops. So that means AMN and angle B are corresponding angles. Okay, so then side MN is parallel to the side BC by the triangle midsegment theorem. So we know angle AMN is congruent to angle B by the corresponding angles postulate, because we said those were corresponding earlier. So we know that these are parallel. We know these are congruent. That's all we've talked about so far. So the measure of angle AMN equals the measure of angle B because congruent angles have the same measure. So side AM is congruent to AN. And since that's true, the measure of angle ANM is the same as the measure of angle AMN. So these two are congruent as well, by the isosceles triangle theorem. Remember that said, if we know that these two sides are congruent, then their angles are congruent also. And then we know that A and M, well, since we know angle B is 75, we proved that AMN is the same as B, so that's also 75. And then we said, hey, angle N is the same as angle M, so that's also 75. So the measure of angle ANM is 75 degrees. Okay, we are going to skip number 3. There are 3 check for understanding problems to do that I think you can handle. In the first one, they tell you AB is 10, CD is 18, and you're going to find EB, it's this side, BC, and AC. Okay, so you need to find those 3. Then, number 2, you're going to find the measure of angle ZUV, that's this angle right here, and you're going to tell us why your answer is correct. And number 3, side CD is a new bridge, so right here is our bridge being built over a lake as shown, and you need to find the length of the bridge. So use the information there to help you. Okay, go ahead, get started on those problems. If you have any questions, make sure you're asking, and there will be a video to check your work posted as well.